We're here in the Advanced Technology Center in Cupertino, California. And if you've heard anything about this project, you've heard how big it is. So let's just talk about that. I'm standing in the middle of a computer system with 128 processors, a quarter of a terabyte of memory, and 111 terabytes of disk. The total rotating mass of all these disk drives, over 2,000 pounds. That's like spinning a fully loaded Porsche at 10,000 RPM. Now, where I've come from has been said, don't sweat the details. Well, I'm here to tell you, sweat the details. We've got 100 billion call detail records in this database. Now, if you were a retailer, that would be point-of-sale transactions, or a finance company credit card transactions, or if you were an e-commerce site, that'd be clickstream. One row in the database for every click someone does with me. Now, I don't just have this information, I use it. That means that when a customer calls, I know what to do. Every time a customer clicks on my website or calls my call center, I got an opportunity to either annoy them or to do something meaningful. Now, how do we do this? Well, you have to know everything about this customer. You have to know their age and where they're from, as well as what they've done with me since they became a customer up until a few seconds ago. And you have to be able to use that knowledge in real time as you interact with the customer. Now, what I'm about to show you is a solution that we built using the best we got. Reliance, Alpha Servers, Himalayas, some of our best partners, all put together into a solution that's a kind of a different way to solve the problem. What you see next to me are a rack of displays that show various statistics about the system. We have things such as the total calls, total dollars by day. There's really counts of our transactions and statistics about them. We have things like the total number of transactions in the database. Currently we have 103 billion phone calls in the database. We have statistics about performance that we'll come back to. And we have things like total calls by day of the week or day of the month and so on and so forth. The monitor I want you to look at the most closely right now is this one in the middle. And this is the total number of transactions per second that we're inserting into the data store. Every time a phone call is made or every time a customer changes their profile, we immediately insert that into the database. Here we're doing around 12 to 13,000 transactions per second. That's roughly like all the phone calls in North America at the same time. If you were a retailer, these would be point-of-sale transactions, or a telco, in this case it's CDRs, or if you're a bank, it might be credit card transactions. Or if you were an e-commerce site, this might be clickstream, one transaction for every click in the database, for instance. So that's a high volume, but obviously we want to kind of push things to the limit here. So to show you what we can do, we're going to push it to about 300% of the normal rate. And as we do that, what we'll notice is that the 128 processors in the system will begin to be very busy. And you can see that on this performance display hanging over my head. And that's the CPU utilization of the entire cluster. And then within a few seconds, we'll notice that the calls per second will begin to ramp up very dramatically until we hit around 30 or 40,000, or roughly the phone call volume of the top 5 telecommunications companies on Earth combined. Okay? So this should be able to handle just about any clickstream or any retail environment on the planet. Now, as we start to move data into the database, we might think about ways to get it back out again. And one of the things we want to do is tap this transaction stream to be able to use it to feed to other systems or to look at it in real time. As an example of a feed to another system is we might propagate data from this operational data store in real time down to a data mart. In our case, we have an Alpha server. It's an 8-way Alpha server running a very large Oracle data mart that tells me the total credit given or extended to any customer at any given time. And what we see here is a display that shows that we're currently updating about 350 rows per second into that database. It's all of my corporate accounts, key customers, and it's a running total or an updated total of the balance of how much credit we've extended to those people as we go. Now, another way we might use this online data stream is to be able to tap an individual event and let people know when it's occurred. And an example of that would be I could go in to a screen that watches for a specific phone number to be called. I'm going to tell it to watch for this specific number. Now, if this was a retail environment, we might be doing, for instance, I want to know when the sales velocity of a certain item exceeds 2 times normal, or I might be looking for a fraud situation or something like that. And if I actually make a phone call to that number, what it'll do is it'll dial into my switch simulators here that are inserting all these phone calls. And it'll insert this one phone call along with all the other ones that are coming in, the 10 or 20 or 30,000 per second. Within a few seconds, that phone call will land in the database and we'll detect it coming through and immediately notify this application that we've caught that call. And you see it came in here. We called the 406 number, okay? Now, the other way we might use all this detailed information is we might want to use it to interact with customers more intelligently. And this is key. I have a moving snapshot of all the customer data, their demographics, the accounts that they own, the plans they have, and all of their transactions up to a few seconds ago in the database behind me. So I could use that to be able to more effectively work with my customers. Okay? If I go, for instance, to a data mining environment that we have integrated into this, let's say I create a new product. And the new product that I create is what I'm going to call Auto Redial. And the Auto Redial product is basically a product that says every time a customer calls and gets a busy signal, they can press *33 on their phone, for instance, and it'll automatically redial the number when the person gets off the line. Okay? Now, to understand who might buy Auto Redial, I run data mining. And in data mining, I would push a button and he would extract, it takes about 10 minutes, he would extract 1 million customers out of the database into an NT cluster behind me, and we would mine on that. And when we do the mining, what we end up with is we end up with a model that looks like this. This is all the customers I extracted. And I see that the highest predictor of whether somebody will buy Auto Redial is how many low duration calls they had in the last 24 hours. Busy signals. How many people got busy signals? Because, you know, Auto Redial, you would imagine, would be triggered by busy signals. The second highest predictor is if people had more than 13% of their calls were busy signals, then the second highest predictor is the type of line they have. And if they have a cell phone, line type 2, they have a high probability of buying this product. And it goes on. They have high income. They have a lot of daytime phone calls in the last 28 days of their history. They have a lot of high duration calls or low duration calls during the day and the weekdays, and so on and so forth. So I've mined on the detailed data to build that model. And now I want to apply the model. So what I can do is I can actually go to deploy the model, and we do this differently than most. We would build a set of rules automatically off of that model. And the rules are just what you might imagine. It's low duration calls greater than 13%, line type of 2, income greater than 79,000, and so on and so forth. And then with the push of a button, we would deploy those models back into the operational system behind me. And it works like this. A customer calls up or clicks on my website. I pass their customer identifier to a set of Java servers running on the operational data store, and they look at this person's detailed history up to a few seconds ago. We look at their demographics, we look at their call history for the last 28 days, and we look at the phone calls they've made in the last few seconds. And all of that combined tells us what product we should offer them. Most of the time, we don't offer them a product at all because we don't have the right fit. And it's better to offer a customer a meaningful kind of relationship than to just annoy them with trying to sell them things over and over again, okay? Now, if this was a clickstream environment, this means when I'm making the 5th click on your website, I could be looking at the first 4, all of your buying history, all of your click history, and all of your demographic information to decide what's the right thing to do as I interact with that customer in real time. To show you that, I'm going to bring up a customer service environment that we have. And in customer service, if I take this particular phone call and I do one of my transactions, this one is just show me all the transactions that I've done today. And I look at the raw transaction detail for that customer today, and I see that there are several phone calls in their immediate history, okay? And I also notice at the bottom, the cross-sell, he's saying don't sell anything to them because they don't fit the model. Well, this customer I know is very close to fitting a model, but what they're missing are those zero duration calls, those busy signals. So I'm actually going to automatically, or manually I should say, insert 2 busy signals into their immediate history. And once those busy signals are inserted, then I should be able to go and look at this customer again. And when I run that model, it should automatically detect that they now fit the profile. So as I refresh, I see now 2 busy signals, 2 zero duration calls here. It's offering to sell them the Auto Redial plan, okay? He did that because he's looking at their transactions up to the second. Now the last part is, if the customer buys something from me, I have to go update the operational system. And I have that here. I have an Oracle operational database, and that thing is synchronized, as I mentioned earlier, in real time with the customer data in our data store. So when I accept the offer from the customer, it'll actually reach through using a message broker product and update both of those databases. And this person's calling plan, which used to be the 600 minute a month plan, if I update them, I see that they're now on Auto Redial. Okay? Both databases were updated and synchronized in real time. Now, to do one of those interactions is fairly complex. We're using a rules engine, and that's being run online against billions of transactions and millions of customer records in our database. But we need to do more than one in the real world. So we're actually going to simulate something like 1,000 interactions happening per second via our website or through our call center. And you'll notice the system now gets extremely busy as we start to pump up these rules being applied in real time to these customer interactions. Okay? And we'll also notice on the monitor over here that we're now running something like 1,000 transactions per second. and roughly a tenth of a second for each interaction. And 1,000 transactions a second would be something like 40 or 50,000 customer service agents online using our services through the web or through a call center. Now, the last piece that's interesting is I've built the model of a customer likely to buy this product. And I'd like to understand just how many customers would ever really buy the product. I've got all the detail in the system behind me to answer that question, and this is a one-time question. I wouldn't build a data warehouse, for instance, maybe to answer this one-shot question, or a data mart or so on. So I can actually just take a query and launch it directly into that infrastructure behind me. Here I've built something in DSS Agent that says, tell me all the customers who have high income, cellular phones, a lot of low duration calls, a lot of daytime calls, so on and so forth. And if I just launch that online query, we'll see that the system then will begin to plow through millions of customers and literally billions of phone calls, and we'll find that the system will begin to find just which customers are likely to buy this product from me. And the other thing that's interesting is, even with the system flat against the wall, doing thousands of inserts, thousands of customer service interactions, and this massive parallel query, we're still executing at the exact same response time of about 1/10 of a second per interaction. The ability to mix all these workloads together, to propagate information through an enterprise in real time, to synchronize all the various aspects of a business using a message broker and this operational data store, and the ability to use all this detail in the database to be able to make interactions with customers meaningful by using up-to-the-second information as well as all of their history each time they connect with me, is what we think is really going to make the difference in how businesses deploy applications in the future.